I have a horrible procrastination problem. I've been trying to get this video made for a long time, but I just kept putting it off because there was no real deadline on it, but enough's enough. So back in January, I set up this sort of experiment here. I'll put a link to the video, of course, in the description, and I'll try to make it appear here on this video too, so it's easy to look at. But I just set up this experiment with 3 identical collections of 3/4 inch, I think it's 3/4 inch, no, maybe it's 1/2 inch, with 1/2 inch plumbing fixtures, fittings and pipe. And I set it up with one with an electric anode in it, and one with a magnesium anode in it, and one with no anode in it. And the reason was because I have a heat pump water heater, and I had just pulled the anode from the heat pump water heater. It had been installed for, I guess, 4 years. Looking at the date on the thing there, and you can see there's a lot of magnesium remaining on it. But up here at the top, it's like all gone. That was kind of interesting. It's just where it gets near the junction, it oxidized a lot more in that section. But the whole rest of it, which it was a full length, I had to cut it off because I don't have enough headroom clearance here in my basement. But across the whole length, it had this much remaining. So quite a bit remaining after 4 years now. I guess it depends on, I'm sure it depends on your water chemistry and how much water you're using. But, and I don't use that much. So I had a lot of time left on it, but I didn't know how much time I had left on it. I guess I could have pulled it and looked and seen a lot left and then put it back in. But I wanted to replace it with an electric anode, similar to this one, which is what I did. But then I thought, well, how do I know if that electric anode is doing a good job? So that kind of gave me the idea to put this test up to see what happens with 3 different anode situations. And I just used tap water, no treatment or anything like that, just cold water out of the cold tap to fill these 3 buckets. And I submerged these guys. I had the water level up to here in each of them, and I maintained that level for a long time. When it would go down a ways, I would add more water. But I was trying to be very careful. I wanted to add water very carefully so it didn't disrupt sort of the pattern of the corrosion and of the rust. And here you can see where I was adding the water, even though I tried to add it very slowly, it still moved away this section here. And so then when it got close to the end of winter, as I record this, it's June. As it got close to the end of winter, I stopped refilling it because I thought, you know what? It's a pain to have to keep refilling these. Plus, I kind of wanted to see what would happen as the water level went down. So it kind of gave a good result. So I'll explain. Before I stopped emptying it, there was no corrosion anywhere on the pipes, on these vertical pipes. So anything you see here, any corrosion you see here, except for this part that's out of the water, that got a little surface corrosion. But any corrosion you see here, or this and this is probably calcium and other minerals from the town water that you see here, the white. Any corrosion here occurred after the water level dropped away from there. And you can see over here, the part that's still underwater is free of corrosion. And I want to talk a bit about, so I guess what I'm saying in general is the electric anode seemed to perform quite well. Now I was disheartened because almost immediately I saw this rust at the bottom, and that's where it is. I don't know if you can tell, but the rust is just lying at the bottom of the bucket. And I was disheartened because I was like, why is there all this rust in the bottom of a bucket with an electric anode that's supposed to be preventing any oxidation? But what what I came to believe is this rust is not on the metal. It's, and I'm gonna do this. I'm gonna flip this stick around. I'm not touching the pipe. I'm just moving the water near the pipe, and you can see that was just rust powder that had settled on the horizontal section of pipe. You can look down there, and I'll zoom in. I could take this out, but then it's going to be a watery mess. I'll zoom in on this thread. Now you see, oh, look at how it's focusing on the water. Okay. Come on, cut it out, phone. You can see this thread is clean. There's no corrosion on this thread at all. And you know, if you've worked with pipe, if it's in water or in a wet environment, those threads especially will get corrosion on them very quickly. Like within the same day, you'll see a surface coating on there, and then it just, if there's remaining moisture on it, it will continue to corrode. So again, over here, let me zoom back out. Sorry about this. Over here, you can see this pipe. It's just, there it goes. It's just rust that had settled on it. So what I believe it was I believe it was the iron in the city water that initially was in the bucket, plus from the additional water I added as the water evaporated out of the bucket. I believe this was iron that was in the water itself, and that just settled. It just oxidized into rust powder, basically, and then settled down on the horizontal parts of these pipes. So my feeling on this electric anode is it worked really well. This one was a cheap one. There's a couple different ones out there. There's a, what is it, ProTech? Something like that. Oh, here it is right here. This is the good thing about never throwing anything away or cleaning up your basement. This is the one I put in my water heater. It's a ProTech. And that one's expensive. That's the one, when you look on Amazon, there's one that's more expensive than all the others, and that's the one. And I got it because it's a one-time expense. I'm not, it's going to last. I'm going to keep it in here for the life of the water heater. So I didn't mind if it was, $40 more or whatever. But then this one, for this experiment, I used one of the no-name ones. And clearly it's a Chinese knockoff of the ProTech, which I assume is also made in China anyway. I'm looking. Oh, made in Canada. My mistake. So the ProTech, according to the box, is made in Canada. But this one seemed solid. Everything seemed good about it. It's stainless steel, and it has a titanium, right? Alleged titanium anode. And I have no reason not to believe it because it looks good and it worked. This thing worked. It kept the corrosion off of the pipes that were submerged. Now, when you'll notice, let me lift this up a little bit. Once I let the water level drop, the corrosion's attacked the pipe. So I let this happen this spring is when I started to let it evaporate out without refilling it. And the corrosion attacked the pipe that was no longer... The pipe was no longer in the solution, in the water. So the electricity, the electric potential that's on this thing, it could not affect the pipe that's outside of the water. The water is part of the circuit. And in fact, let me do this. Let me see if this works. Okay, up here, oops, sorry, I'm an idiot. I put my phone to sleep. So up here is the power supply for the electric anode. And you see the green LED up there. So now I'm gonna lift the anode out of the water. Look, and this is I thought this was cool when I installed it. I noticed this. That green LED is, I'm lifting and lowering the anode in and out of the water. So that's pretty cool. The green light does indicate when the circuit is complete. turn my light back on. When the circuit is complete, that green LED lights right up and lets you know it. So for example, here, I just used this clamp to, you know, physically attach this electrode to this part of the anode. This is the strap that normally you'd attach it to the chassis of your water heater. Okay, so in my experiment, this part up here is electrically equivalent to the chassis of the water heater, so I clamped it there. And water's crappy now, so you can't see, but look. I mean, this thing is spotless. And this is the no-name knockoff one, so I'm real happy with it. They sell them, they're sold at different sizes according to how much the capacity of your water heater is, but in my mind, this thing, it worked great, and I don't see any reason why I'm going to have any corrosion to speak of in my water heater for a long time. So I'm happy about that. I was also interested because you know, of course, I'm interested in corrosion on my boiler. And so I'm going to make a separate video, I guess, because this video is going to be too rambling, about this experiment where I have kept on my boiler now since November. I've kept this experiment going. I'll make another video about that one. Anyway, this is just regular tap water, and then this is tap water with a little bit of 8-way boiler product added to it. So that was an experiment also to see how that corrosion is affected. But back to this one. So then the next one was a magnesium anode, and this was a small one that sold for use in RVs, right? RV water heaters are very small, so this one I actually got it came in a 2-pack. Where's my other one? I was going to show it to you just for fun because I think it's right here somewhere. Well, this is how not to be prepared to make a YouTube video. Can't find it. Anyway, you can see what it looks like. It looks like an anode, a magnesium anode in this case, but it's pretty small. This is smaller than what you would use in your household water heater. It's only about, I don't know, 6 inches long or something, but it's for an RV. But for this experiment, it was great. Now, the cool thing about this one, or the interesting thing about this one is, when I had the water all the way up here, of course, there was none of this happening. This is corrosion that occurred after the water level dropped on this part that, again, is not electrically protected by the anode, right? When I started this, the magnesium bucket here was the cleanest. So you'll notice it didn't have that brown rust-colored settlement down there at the bottom, and I don't know if the magnesium interacted with the iron in some way to prevent the little iron particles from turning brown. I don't know what was going on, but this one was crystal clear. Now, as the experiment went on, I started to get some of this material on the top floating on the water, and it's probably from adding the household water to replenish the evaporation. I was adding a lot of, calcium and other minerals and iron to this tank, to this thing here. But the cool thing is, and I don't know if you're going to be able to see it. Oh, no, I can't see it. We can see it from the top, though. There's a pile, of what I assume is magnesium oxide. It's very dark colored. I wish I could get this. Let me try to get this stuff off of the surface here. It's not going to work. All right, I got some off. This is a pile, and you can't tell in this image here, but it is like 3 inches high. It's a cone. Damn it, this thing always gets there and blocks the camera every time. It's a cone of powder that just built up directly below the anode, And it's about 3 inches high, and it looks like a volcano. Can't tell from here. Let's see if I can make a window. Oh, this is good. Yeah, my tank here, my bucket here. There it is. Look at this. Okay, you can see it's like it's going right up to the anode there. Now in a water heater, this would never happen because these little particles would get swirled around and they'd get flushed out with the water usage. You know, this magnesium, I assume magnesium oxide or something is what these little powdery particles are. But it made a little mountain of them right under there. So you could see the magnesium anode getting consumed, you know, just within a few months that I had it sitting here. And again, this was just in this much water. So it was consuming it. But, you know, the anode still looks up to be about the same size. I'm going to go ahead and pull it out. There it is. It's about the same size as it was originally. Let's see here. But you can see it kind of gets, oh, look at this. Okay, this is cool. So in the middle here, I believe, is the steel core. And this is really cool. Hang on a sec. I didn't know it was doing this. All right. Try to get my camera here. I really apologize for this camera work, but you can see that it lost the material. Non-focus. It lost the material from the bottom first here. And it was just, you can see it was like flaking off and then falling onto that pile on the bottom of the bucket. Now up here you can see it was coming off the sides too. You can see how it is, it's breaking off in sort of like flakes or vertical veins or something. It made like little canyons in it. So that's cool. So that you see what was happening. It was rusting away. I'm really zoomed in here, but it was rusting away and these chunks were falling down. And again, this water was just sitting here for these months. I wasn't doing anything with it, or, you know, I don't know, I wasn't heating it. I wasn't doing anything at all. It was just room temperature water, tap water this whole time. All right, just for fun, let me go and try to get some of this. Oh yeah, this is crazy. All right. So it feels like fine sand, and it was kind of like almost cemented together. I had to sort of break it off of the pile, but now that I've broken it, it's very, like, I don't know, sandy. It's just little particles of what? Magnesium oxide. It has to be, I guess, right? And it's very like powdery and silty, and yeah. All right. So that's that one, and it did an amazing job too. Okay, here we can see on the top half this white material. Didn't happen from the beginning, but after some months, this white material started to form, and like I said, I think it is like a combination of the minerals that were in the water that I was adding, because they precipitated out. They just fell down and settled on the top half of the pipe. But then on the bottom, again, with the threads, you can see there's not corrosion happening here. Everything's nice. There's a little, again, collection of stuff here. Now down here, there is a little bit of corrosion on the very bottom. And so, you know, it's funny because someone on heatinghelp.com said that these work in a line of sight situation, because someone was talking about using these in a boiler, these anodes. And the person said, well, in a boiler, they said this works in line of sight, and I didn't really believe it much, but this lends credence to that, because now maybe it's because it was in close proximity to the bottom and up against the bottom, maybe that prevented, I don't know. This one also was not in line of sight and doesn't have that. So just right here on this area, there's a little iron corrosion. This one too doesn't show any. And there's a little hiding under there. Yeah, so maybe, I don't know, this, and then this doesn't really. So I don't know if it's line of sight kind of thing, or maybe it's more of like a, where the easy circulation was, where maybe this water didn't circulate ever when I was pouring new water in. I don't know. But regardless, the magnesium does its job, and I think everybody knew that. Like, no one doubted that magnesium prevents corrosion. And I say that even though people have magnesium rods in their water heaters, and their water heaters still fail after, 8 or 10 years. And even sometimes I've heard anecdotes where people said they replaced the rod every few years and it still rusted out. So it's too little data that we don't know, but this did definitely reduce the oxidation. The magnesium did a great job, and the water was clear. Like, this orange stuff never happened, and you can see in this one now it's all mixed. It's mixed around in the water because I disturbed it, but this water always stayed really nice looking, and it seemed like it was eating up the rod. So enough yapping about that. Now then, the control, right away, this one got very rusty, very fast. And again, it wasn't made as bad as what we're seeing up here. This happened after the water. I let the water evaporate away from this top part. But yeah, it's the nastiest of all of them on the threads. I mean, they're bad. They're already starting to get caked and weird. The other threads, even though they were exposed during the same amount of time, they don't look nearly like this. And then down here, again, we can see some of this is settled, but I think we're going to find out that some of it is actual corrosion on the pipe. But you can see that a lot of this material sitting on top of the pipe is just like the other ones. It's from, I believe, iron settling out of the water that I added. Yeah, in fact, this is interesting. This doesn't even look too bad here on this part of the pipe. You can see where I just scraped it with my, gross. Well, that's a difference. I don't think I saw that too much, but yeah, this is kind of interesting. The pipe here doesn't look too bad on this part. Let me see how it looks. I'm making a mess. All right. These, I gotta say, these threads don't look too bad here either. So, they're way worse in the on the part that got exposed to air. And I guess that's not a surprise. We know that it's the air, it's the oxygen that is causing the corrosion. So there's a lot less oxygen in this submerged part. So this is pretty good. I mean, this doesn't look too bad. I can't, I don't have any way to tell exactly how much corrosion occurred, but it doesn't look bad at all. So, okay, that's a good lesson. This is not what I thought this would be worse. The amount of this oxide material that settled on these pipes is way more than it did on the other ones. But as far as actual corrosion here, it doesn't look too bad. I guess that's why these water tanks last for several years before they start to go. So I guess if I'm really being fair, when I look at this, I have to say that for the submerged portions, yeah, there's more rust, more visual of this rust here. but it doesn't look like, you can't see where it was, for this length of an experiment, you can't see what it was attacking being any different than the other two. So, yeah, I don't know what the lesson here is. It's not, it doesn't look bad. This part's a different story, okay? The air attacked this, and it's a nightmare. Like, this is crazy up here. This is already getting those chunky things on them. Takes way longer, I guess, for this to happen underwater. So that's good. That's cool. So yeah, I don't know what we learned now, and after seeing this, I don't know what we learned, because I don't have enough evidence or data to be able to say, yes, you know, this is more corroded than the other pipe. I can't tell just from looking at it here. So possible useless experiment, but it was still kind of good to see how they compared and what they did. But so I don't know. I would say it don't cost much to have an anode in your water heater. You might as well do that. As far as in the boiler, I don't think that I'll be, even as crazy as I am with this boiler, I'm not going to put an anode in this. Like, I could take this out and I could put an anode right here, but it would only be in the first section, and it's possible that that it wouldn't affect the other sections. I don't know. But I've got, with my water treatment that I do in my boiler, I already have so little corrosion, there's no need for me to try and reduce it more with an anode. So there you go. The great anode non-experiment of 2025 is concluded. If I think about any more things to say about it, I'll put them in the comments or something, and you can yell at me in the comments. Bye.